we know that comets are not in our atmosphere? How did we come to learn this? And what does it say about science? So I want to take everybody back to the 1620s, around 1622 to 1626. There was the so-called controversy of the comets, where there was a debate between my hero and your hero too, after whom you've named your project, my hero, Galileo. So I always have my finger puppet of Galileo. So Galileo was actually wrong, and he thought the comets might be in the Earth's atmosphere like meteors, and that they might be not interstellar phenomena or interplanetary phenomena. But he was, of course, wrong, and that was many years after comets had kind of been shown to be very far away from the Earth, but perhaps not proving that they weren't in our atmosphere. What do you make of the history of all this? That we came to learn so late that comets were not like meteors. The comets were not in our atmosphere. They were something from far beyond. What do you make of the great scientists that can be right about some things and spectacularly wrong about other things?
Well, our imagination allows us to think about many possibilities, and all of them except one applies to the physical reality we all share. And very often, the truth is something we resent, and because a virtual reality makes us happier, and that's why a lot of people prefer to take recreational drugs. I know that now the metaverse is not a business anymore, even though originally Mark Zuckerberg assumed that people would love to live in the metaverse by putting goggles on their head. The point is, physics is a way of us narrowing down possibilities using experimental data, evidence, and we learn about the laws of physics. And if something is relatively low in the atmosphere, there is friction on air, and it wouldn't survive in that orbit. In fact, satellites do go down if they are sufficiently low in the atmosphere. Uh, and if there was a satellite that was launched by the ancient Romans at around 1200 kilometers, we would see a Roman satellite coming down. We haven't seen that. I mean, the only thing we find from the Roman Empire are archaeological relics, and nothing in the atmosphere, nothing like satellites. So they didn't have advanced technologies. And of course, the farther you go back in time, the higher the object needs to be in order not to come down as a result of friction with air. And what we see about comets is that they actually move way far from Earth. We can figure out the distance because we can follow their trajectory, and they are influenced by gravity. And their distances are comparable to the Earth-Sun separation when we see them. They are basically icebergs that originate from the outskirts of the solar system, where water ice was condensing around the rocky material. So they're sort of like dirty ice balls. And Fred Whipple, a Harvard astronomer, was the first to recognize that nature of comets by going through Harvard Square during a winter day. And as you may imagine, it was snowing, and the kids were throwing ice balls. And he just thought, well, maybe comets are made of the same thing, dirty ice balls. That's what his model was all about. And indeed, that's what we now understand as comets being. They are sort of a mixture of ice, water ice, and rock. And from the early formation of the solar system, these are the relics that are far out. And of course, closer to the sun, you end up with just rocks that may have lost their ice. These are asteroids. And so we find two types of objects quite prominent in the solar system: either asteroids, the bare rocks, and the comets that are icebergs. And those comets are losing their water as a result of getting warmed up by the sunlight as they come close to the sun, and that results in a cloud of dust and gas surrounding them. And the dust and gas are pushed away from the sun, the dust by the solar radiation, and the gas by the solar wind. And as a result, you end up with a cometary tail that is the characteristic feature of comets.
So, speaking of things that aren't in our atmosphere, recently you posted on your Medium, Avi-Loeb.medium.com, what will be the content of the website aliens.gov. So it made me, I wasn't aware they were going to actually launch this website, but I went to the website, Avi, and it's really a thing of beauty. There's it says this site can't be reached. So I'm sure that's going to put to rest all the notions that the government is, concealing information about aliens. What do you make of this? Some say, cynically, that the attempt to disclose or announce and keep teasing and hinting at a disclosure is just a giant distraction. They always accuse it of Trump distracting from the Epstein files. What do you make of all this, Avi? And what do you make of the content, of the future content of aliens.gov? Do you think that was a good
Well,
choice of names, by the way?
so, well, I think the Pentagon is thinking about releasing some information, and the Secretary of War, Pete Hegseth, shortly after President Trump announced, gave a directive to the Pentagon and the intelligence agencies to release any information related to unidentified anomalous phenomena, extraterrestrial life, or anything to do with these interesting subjects. The Pentagon is planning to do that, and it's not surprising that the White House secured these domains. Now they don't have websites associated with them because they just secured the domains in the last few days. And the question is, what kind of content will be there? And you can think of either an optimistic best case scenario or a pessimistic worst case scenario. The best case scenario is that we will get access to imagery with high resolution. For example, the US government satellites that are routinely monitoring the Earth, they may have noticed objects with moving in ways that our best technologies cannot reproduce. That's quite possible because when you look at Earth from a satellite, you know the distance, right? Because the satellite is moving and the object is moving. You can figure out the velocities and accelerations of objects that are looked at. And in fact, the resolution can be better than 10 centimeters. I mean, you can resolve objects quite well with present day cameras on satellites. So if we had a high resolution image of an unusual object in the way it looks, it doesn't look like human made drones, balloons, airplanes, or anything else. And it also moves in ways that exceed the performance envelope of human-made technologies. That will be quite intriguing. And then the question is, what is it? What kind of technologies are being employed? So that's the kind of imagery of videos that could be extremely revealing that we are dealing with something else and we should figure it out. And obviously, I would be extremely excited if that happens and be happy to help the US government figure things out. The reason they're speaking about this as related to aliens or extraterrestrial technologies is probably because they ruled out the possibility that it relates to adversarial nations. So that's the optimistic scenario. If they have access to that data, we don't know. There could also be some materials that they retrieved. I don't know if they have it or they delivered it to corporations and so forth. But one thing is clear, that the government is not a scientific organization and their day job is national security. So they put this data aside if it's not related to adversarial nations. And also, they don't want the US Congress to look over the shoulder and say, you're not performing your job. We are putting $1 trillion into the defense budget for 2026, and you are still unable to figure out what things are. So to avoid this scrutiny, they might classify it and not even let others know about it. And perhaps this release would give us some information. Another possibility, which is the worst case scenario, is that we'll see some documents that are redacted. We know the feeling already from the Epstein files, and that it will be full of inconclusive statements that we can't make much of without much scientific quality data, and that will only fuel conspiracy theories. I fear that we might be in that situation. We just don't know. So let's wait and see what is the content that is provided on these websites. I'm sure there will be something, because both President Trump and the Secretary of War, Pete Hegseth, said that that this will happen, and it may happen relatively soon, or it may take more time. That depends on the level of classification of the information that they're planning to release. the question is there something
Right.
that we should think about, and I don't know the answer to that because
Right.
I never signed a non-disclosure agreement, and without evidence, without data, I really am very reluctant to believe storytelling.
Yeah.
We know about a lot of people who tell stories that are not substantiated. We know about eyewitness testimonies that put people in on death row, and then DNA tests exonerate them. So the way science makes progress in our knowledge is not based on what people say, but based on the evidence collected by instruments that have no wishful thinking. That's the key here.
Right. That's what another Galileo quote, that our job as scientists is to measure what's measurable and then make measurable what is not yet so. And from our conversations in the past, I know that you guys have an unlock sequence, a code, kind of a rubric that you'll go through if there's an evidentiary, claim made. What is the minimum standard, in terms of evidence that the government should use before it posts something, on aliens.gov, or has some press conference and something like that? If you're
So
advising them, what's the rubric?
yeah,
Go through the unlock
so
codes.
it must be evident. If you want to claim that it's not human made, it must be clear. There must be clear evidence for the either velocity acceleration of the object exceeding anything that humans can produce, or that the imagery of the objects appear to indicate something very different than what we are used to from all the technologies that we possess. And for example, the Galileo project that I'm leading built 3 observatories over the past 4 years, and the most sophisticated one is in Nevada. It has 3 units, and as of last month, we use 3 units to triangulate and figure out distances to objects in the sky. So that is key. Knowing the distance is key. And so far, whatever imagery we have seen in congressional testimonies had no distance measure. I mean, we could see an object moving, but you don't know if it's moving fast because it's close to the camera, or because the camera is moving relative to the object. So distance is key, and in any such data released by government, I would like to know the distance so I can calculate the velocity based on the angular velocity, and then the acceleration and so forth. And also, if they have any material evidence, that would be amazing. And if people might say, well, if the data was collected by classified sensors, or the data is unclear, maybe we shouldn't release it. It should be classified. But my point is, if there is data from decades ago, let's say 50 years ago, it's completely irrelevant to present day battlefields as to what technologies humans were using back then. So if there was anything unusual back then, we should be able to look at it. And it's all about the evidence. And let's put it out and figure out what it means in the standard scientific way. And if there is any doubt about whether we should release it or not, I'm happy to help government figure it out. You see, I'm interested in knowing the answer. You can think of me as a kid, and if there is something that is truly out out of this earth, I don't really care what the Nobel Committee would think about it, if they pay attention to it or not. If they invite me for a cocktail party in Stockholm, I would really not spend time on it, because this would be far more exciting, for us to figure out if we have a neighbor, and if so, what can we learn from our neighbor. We can't hear you, Brian.
Sorry. A layperson might want to know, what do we do next? Why is this so controversial? Why do we keep getting teased, disclosures coming? There's movies about disclosure, and there's bombshell revelations, and then
Right.
I mean, it's imagine if you had a press conference, say it was about discovery of inflationary gravitational waves at the Center for Astrophysics, exactly 12 years ago this week, on yesterday, St. Patrick's Day, 2 days ago. Imagine, and you're a part of it. You're the director of the CFA at the time. And then, like, nothing, we're going to make an announcement, but then we never make the announcement. Okay, we made the announcement. We had to retract, basically, the claim, as you know, and as I've written about. But the announcement of the announcement, it reminds me of my friend. He's a bachelor at my age, and he's in his 50s, and he's engaged to be engaged to be engaged.
Right.
It's what is the benefit? I mean, doesn't it undermine even if it is a distraction and a psyop, as they say, from the Epstein files, which I'm in, by the way, because Epstein sponsored a conference at UC San or near UC San Diego that I was a speaker at. I'm not, he didn't know me or mention me or anything like that, but it shows you the influence of big money. And let's say it was a distraction in the government, and Trump wants to Hegseth, or whatever, whoever it is. Why would they keep failing to deliver anything? What
Right.
is the
So
possible motivation?
one motivation could be that the US develops very advanced technologies and they want the public to be confused if they happen to witness those.
Mm,
That may be what happened in Area 51. That may be, in the early days of the B-2 bombers, they didn't want people to know about them. And so it's quite possible that there are very advanced tools being used already now, but the public is kept in the dark and on that, and moreover, in order to confuse the narrative, they introduce the alien component to it. And for example, another possible reason is, suppose there is a retrieval and reverse engineering program within government related
mm,
to adversarial nations. Whenever there is a crash of, let's say, a Russian or Chinese airplane or missile from Korea, whatever, there is a whole program trying to figure out the technologies being used by retrieving those materials. And of course, it may involve pilots, and you might want to confuse the subject by saying, oh, this is just alien pilots and alien technologies that we are looking at, and there is this program. And some people may not be privy of the details, and they hear, some people within government hear these rumors as if it's really alien material. So there could be many possible reasons to confuse the public that have to do with national security, and then there would never be any substance behind them. And
mm.
so to figure out if it's a smokescreen or not, we just have to look at the evidence. And I frankly do not get excited until I see the evidence. Where is the beef? Okay, so as long as people just tell me stories, it's not convincing. But one thing is clear, that there are objects, and former President Obama talked about it, and current President Trump said it's classified when after hearing him speak about it. It's clear that there are objects that the US government cannot figure out, but whether they're human-made or something else is unclear to me until I see the data.
Yeah, I mean that was very surprising on a podcast that he, dropped this bombshell, and then the review, the podcast or interviewers, follow up was, basically like, what color is the couch at the new Obama presidential library? It was like zero follow up. I'm like, this could be the biggest, but it turned out to be, kind of a nothing burger, and he walked it back, I think. But
Yeah,
now let's say they come out with the evidence, and it says we haven't found any evidence of anything. There's no evidence of alien life, no evidence of alien crafts. Aliens.gov
good.
is basically a big, a red X. Nothing exists. Does that settle anything, or does it raise more questions, than an answer?
No, I mean, to me, it's all about the evidence. And if they don't show evidence, I would just ignore it and move on. Now, of course, there is a matter of national security, because it's clear that, I mean, that there were reports from the Director of National Intelligence to the US Congress that there are objects they cannot figure out. There are reports of military personnel, of very reliable people that see things they don't understand. Okay, so it's a matter of aviation safety. It's a question of whether we are, there is espionage in the sky. We know about the Chinese spy balloon. Okay, and so that was found by citizens because it was big, but there may be a lot of drones around that are being used for espionage, and the US government is not protecting us from that. And we need to know that. Okay, so if in case it has nothing to do with extraterrestrials, let's figure out what these objects are for national security. That's a serious matter. And that's why I would not feel that my time leading the Galileo project is wasted, because the technologies that we develop, the sensors, the machine learning software that we develop, can be used by the Pentagon in the future to defend the nation. It's not a waste of time to figure out things that are not well understood, even if it has nothing to do with visits by extraterrestrials. So we need to clear this up. And I think it's a good subject for mainstream science to figure out things that the US government is confused about, because we're paid by taxpayers, and also there is some remote chance that we might see something we have never expected, which is a visit by some neighbor.
Right. And you mentioned that in a recent article on Medium, which I link to below. It's entitled "Should We Worry About Interstellar Predators, Not Just Interstellar Intelligence?" And the
Right.
money quote was from me is the main scenario we should lose sleep over is of alien predators who noticed Earth a long time ago and decided to monitor the situation, like The Rock or one of these guys. They're monitoring the situation from up close, forecasting that it may lead to the development of space technologies pose a threat to them. Why is this the most kind of insomnia inducing scenario for you?
Oh, because you know the Earth could have been discovered by civilizations around about 1 billion stars in the Milky Way galaxy, because the transit probability of the Earth, I mean, depending on the orientation of the observer relative to the Earth-Sun axis, Earth-Sun, the Earth moves around the Sun in a plane, and it blocks part of the Sun only for about 0.5% of all possible viewing angles. So there is a chance of 0.5% that an observer at a random orientation relative to the Earth-Sun system will see the transit of the Earth and will figure out that there is a habitable planet in the solar system called Earth. And given that 1 billion stars in the Milky Way galaxy constitute about 0.5% of the total population of stars, you can imagine another civilization knowing about the Earth long ago, billions of years ago. And so they might tell, if they have imperialistic ambitions, they might worry about us developing ultimately the technologies to pose a threat to them. And so they might leave some monitors in the solar system, for example, in the outer solar system. We wouldn't know about it because we can see only objects bigger than a football field out to about 5 times the Earth-Sun separation. Beyond that, we can't see enough reflected sunlight from them. So we don't really know what lies in the outer solar system, and it could be that there are some monitors out there, technological monitors, that could respond to whatever happens on Earth relatively quickly. Otherwise, if we just say, oh, they haven't started the journey because they don't know that we develop technologies, when will they know? When they detect the first radio signal that was transmitted from Earth. How far did it go? 120 light years, because the first electromagnetic signals, artificial signals, were produced about 120 years ago. So there is this bubble of about 120 light years in radius that contains of all the 20,000 stars. Okay, only 20,000 stars. Now, if we wait a millennium, then there would be 1,000 times more stars engulfed within this transmission bubble of ours, because the volume grows as the time cubed, and this growth continues until you reach about 1,000 light years, which is roughly the thickness of the disk of the Milky Way galaxy. After that, the disk itself is two-dimensional, so the growth of the volume of the number of stars would go like the time squared, not the time cubed. So, but at any event, if you wait a millennium, there will be 1,000 times more stars aware that we exist. Instead of 20,000, it will be 20 million. And so that's a big increase, and perhaps that's why we haven't heard from any of those. Now, how long will it take any civilization within that volume that alerts them to our technological advances? How long will it take them to reach us? Well, that depends on the technologies they use. If they use a laser beam as their weapon that propagated the speed of light, they can reach us within the light travel time between their location and us, and it could be thousands of years, and if they're at a distance of 1,000 light years, so we still have some time, before we will notice that. And if they use rocket technology, it could take 1 billion years for them to arrive at our backyard. So we have some time before we would know that they noticed us if they're at their place. However, if they realize that the Earth is a potential threat long ago and they came close to us, we might hear very quickly from them. Another scenario that we could hear from is if they produced self-replicating probes that go all across the Milky Way galaxy. They can fill up the Milky Way galaxy with probes, and we would see them as interstellar visitors. And so we should check those interstellar objects that arrive into the solar system from outside. And I should say that, you might think, oh, if we don't notice a spacecraft, then we are probably safe. Not necessarily so, because you could imagine a Trojan horse situation where the outside looks like a comet, whereas they planted some technological gadgets in the interior. That's quite possible. And in fact, if we wanted to venture to interstellar space, I would argue that we should have intercepted 3I Atlas with a capsule that we would send on a collision course with 3I Atlas and plant it in deep inside 3I Atlas, because 3I Atlas is moving out of the solar system at 60 kilometers per second, faster by at least a factor of 2 than any space probe that we launched. So just to give you an example, in November, 3I Atlas came close to the Europa Clipper and the JUICE spacecraft that were launched by the European Space Agency on their way to Jupiter. And they would arrive to Jupiter in 2030 and 2031. That's when these two spacecraft that humans produced will get. But 3I Atlas arrived to Jupiter this Monday. So it was next to them in November. It's already past Jupiter, on its way out. This is clearly a better carrier for any technological gadget that we would like to
But to
send to
be
the.
clear, we don't have any evidence that it's non-gravitational acceleration, or do we?
Oh no, there is non-gravitational acceleration, but it's very small. The
Right.
correction is minute to the
So how much of
trajectory.
that 60 kilometers per second is
Oh,
non-gravitational?
practically, I mean, less than a percent of a percent. It's pretty much negligible.
Would
Okay,
you say that
so
you wrote an article in Medium that I have on screen, or here, let me put it on screen now. There's 22 anomalies in 3I Atlas before it
right.
faded from view. It hasn't really faded. It's just past you. It's still in our solar system. It's still in our front doorstep. So, what single anomaly is the hardest for the detractors who say it's just perfectly normal, not natural thing? What's the hardest anomaly to explain naturally?
Well, there are a few of those. One is geometric, the fact that it arrived in the plane of the planets around the sun to within 5 degrees. That is a 1 in 500 chance. And
Mm.
obviously, people who just assume that it's a comet would argue this is just a coincidence by chance. Another one has to do with the mass and the abundance of such objects. In order for us to detect one in the last 5 years, this is an object that is roughly estimated at 2.6 kilometer diameter based on the latest Hubble Space Telescope images. And given, so one can estimate the amount of mass carried by the object, and it's of order, or at least a billion tons. Okay, so given that mass and the number density of such objects from a parent population, so that one of them would be seen over a 5-year period of the survey, you end up with a certain mass per unit volume of this population of objects in interstellar space. And the other thing that was discovered is that there is a very anomalous abundance of deuterium and carbon 12 relative to carbon 13 that led two papers a week ago to conclude that it originated from a metal poor star, from a star that is old, somewhere between 10 and 12 billion years old, formed early on in the history of the Milky Way galaxy, and also had very little abundance of heavy elements. Now, the problem with that is, even if you take all the heavy elements in stars of that population, all the heavy elements are missing by a factor of 10 the necessary amount of mass per unit volume in interstellar space. So, and I'm not mentioning even the fact that the planetary disks around these stars will carry less than 10% of the mass of the star, so you lose another factor of 10, and then not all the objects will be of the size of 3I Atlas. If you have a mass distribution, you will lose another factor of 10. If you put these two additional factors of 10, you end up with a discrepancy by a factor of 1,000. I wrote a paper about that and submitted it for publication. A factor of 1,000 discrepancy between the needed mass budget and the mass reservoir of heavy elements in the population of stars responsible for this object. Another thing about 3I Atlas is we did some analysis of the 40 Hubble images obtained from the Hubble Space Telescope. And when you remove the circular glow around the object, the coma around it, the circularly symmetric glow, you end up with three jets coming from the nucleus that are equally separated from each other by 120 degrees. A very nice symmetric system of jets. In addition to the anti-tail, again, it's opposite to what you find in comets. And so the question is that a network of thrusters? Why are they so symmetrically oriented relative to each other? And then there was the nickel without iron.
Let me
That
before
was
you move on. You say that for a technological object, a beam of particles might be used to block the solar wind from impacting the nucleus surface at a relative speed of 500 kilometers per second. Are you saying that this thing could be some hybrid thing where it's technology, but it's also embedded within a naturally occurring nucleus?
Well, it could be. I just don't. I don't have a good explanation for all these anomalies that I listed. 22 of them, including the anti-tail. It must be associated with relatively big particles that are not feeling the drag on the solar wind, or they're not pushed back by the solar radiation. And then you have the system of three jets, and the rotation axis of this object is also pointed roughly at the sun, an unusual geometric coincidence. There are lots of unusual coincidences. At the end of the day, you might say that all of them are just chance coincidences. It may well be the case, but it makes it quite a unique object. And I don't think anytime soon, if these are just natural coincidences, we shouldn't expect to be so lucky with a giant object that have, by the way, it's much more massive than Oumuamua, the first interstellar object, by a factor of 100,000. So just think about it. You have an object that is 100,000 times more massive as your third object after the first object was tiny. Why didn't we see 100,000 objects the mass of Oumuamua, before we see one that is as massive as the 3i Atlas? That's another interesting question. There must have been many more small ones than a big one based on our experience with the solar system.
So the other anomalies that is kind of curious to me is that people are often kind of confused what this object might look like if they could quote see it. And I guess the first thing is what was the kind of maximum visibility that it had, and what would, if anything, have made it look strange? That a layperson might recognize if they looked at it through a telescope, for example, which
Yeah,
is
so
far past that.
we couldn't resolve the nucleus of the object. All we could resolve is the glow of gas and dust around it, which includes the jets and includes the coma, the plume of gas surrounding it. By the way, we detected also in the plume of gas, we detected organic molecules, which was quite fascinating. And the methane that was detected, I mean, many of them are biosignatures, but methane was detected only after the passage closest to the sun, which was surprising because the volatility of methane, CH4, is in between the volatility of carbon dioxide and carbon monoxide. And we saw both CO2 and CO early on, and then methane somehow appeared only late. And my fundamental question is this evidence for life on this object? Is it possible that it carries any microbes, and the methane is the product produced by those? There is definitely nutrients for life on this object, and the question is, is it just a dead iceberg, or there is something else there? Um, Altogether, we haven't gotten an image of the central nucleus.
Mm.
The best highest resolution image was obtained by the Hubble Space Telescope. There were 40 images released between November 30th and the middle of February from the Hubble Space Telescope. And by analyzing those images, we could get a sense for the brightness profile of the coma and the nucleus. But there was only an indirect constraint on the nucleus. We could never observe it, resolve it. And you may ask, how can we do better in the future? Well, two ways. One is to design an intercept mission, which would be within the budget of space agencies like NASA and ESA. ESA has a comet interceptor, but it just cannot maneuver by more than 2 kilometers per second. So an intercept mission, just like Juno could have intercepted 3I Atlas if it had all the fuel that it started from. So if you have an advance warning, let's say 6 months ahead of time, you can bring a spacecraft to the path of an object like 3I Atlas. And then coming close to it, the cameras on this interceptor could take a close-up photograph or even land on it and bring some materials back to Earth so we can examine the building blocks of life, whether they exist on an object that came into the solar system after billions of years traveling through space, from another star. That would be amazing. Even if it's a natural object, it's a completely new pathway for astrobiology. Nobody talks about it. I mean, the astrobiologists are focused on looking for microbes through the Habitable World Observatory, remote observing of the chemical fingerprints of microbes in the atmospheres of exoplanets. But here is another way of learning about the building blocks of life near other stars, and that is by bringing materials from interstellar objects that took all this time to arrive to our backyard. We should take advantage of that. And 3I Atlas was one of the best opportunities for that because it came in the plane of the planets around the sun. It passed very close to many of our space probes, and we could have used that opportunity to bring something from it to Earth. We haven't done so. And
Yeah.
yeah.
No, I want to get back to the anti-tail because for experts out there, this was one of the most difficult things for them to explain. Even Jason Wright, your number one detractor, at some level, even he said, oh, there's not 10 anomalies, there's only 4 anomalies, but that was sort of one of them. It's like, well, we don't know, and fine, okay, so we don't know, so it's bad when Avi says we don't know stuff. But anyway, so let's talk about this. There's a 400,000 kilometer long sunward tail, anti-tail with no known cometary analog. So what, in the 6 months since or sorry, a year since we've been talking about this object, what have the boffins, the nerds that are experts? You're not an expert according to like Jason, right? So
Oh no,
you're not entitled.
I published a peer-reviewed paper on the physical model of this antitail. What could it be? What maintains this antitail? I submitted a second paper on this as well, so it's now being refereed. But I should say the first paper that we submitted was submitted to the Astrophysical Journal Letters, and the editor that was assigned to it, she said, this paper is not of interest to the astrophysics community at large. Okay, I said, well, maybe that's the case. Okay, so we submitted it to a different journal, Monthly Notices of the Royal Astronomical Society. It was accepted immediately there. Immediately. Okay, not much. Okay, then I sent a second paper about data regarding 3I Atlas that we collected with an observer, Tony Scarmato, that indicated the rotation of the object every 7 hours. Submitted it to the Astrophysical Journal Letters, got the same editor. She sent the same message. This paper is not of interest to the astrophysics community in general. Therefore, I will not send it to referees. So we had to send it to another journal. Then I sent a third paper where we, together with my postdoc, discovered an interstellar meteor in the latest data from the NASA JPL catalog of fireballs. And it was very clear evidence that many standard deviations had nothing to do with 3I Atlas, had to do with an interstellar meteor. And then the same editor was assigned, all of this within a 3-month period. I write papers all the time about different subjects. I send it because I thought it's significant, and because there aren't many interstellar meteors that we know about. And the response from the same editor was, this paper is not of interest to the general community of astrophysicists.
Wow,
At which
really?
point I said, that makes no sense. So I contacted the chief editor, and when I didn't get a response, I basically wrote an essay just about that. And now the entire world knows the name of that editor. And many people told me that they will stop submitting papers to a journal in which she serves as an associate editor because of the way she responded with a prejudice. Because within the practice that I've encountered before of that journal, my papers were always sent to a referee. Now the referee may say, this is I have some objections, scientific objections, that's completely legitimate. But for the editor to block the peer review process, and so that later they can say this paper was not peer reviewed and not published, so that they can argue that it may not be. That is completely inappropriate, and I call it academic harassment, in the sense that the editor is imposing an opinion and not letting the community at large review a scientific proposal.
Right.
Uh,
And if it
or
had been blind, submission and blind edit, perhaps then it would have been obviously accepted, at least for moved on to
Well,
refereeing, probably accepted.
suppose I was an editor in that capacity, and by the way, the power structure is such that the editor has all the power. I have no
Mm.
way to respond to an editor saying this should not be submitted for refereeing, for peer review. I have no way to object to that because no scientific claim was made by the editor. But it's basically academic harassment. But if I were an editor, and if I were to think that a paper should not be published, what I would do is I would immediately identify a reviewer who I know will say that this paper should not be published, and send it to that a reviewer, and then get the response that it should not be published, and then I'm covered. It doesn't show any bias on my behalf. But doing it 3 times in a row in 3 months to the same author in different combinations in different contexts is what I call academic
Yeah.
harassment,
So,
completely
but
inappropriate. And this is just to show us a phenomena that must be quite problematic to young scholars. The reason I'm able to fight this is because I'm sufficiently senior. I don't care about this editor. I've never met that editor, never had an exchange with that editor. That editor has a bias. Imagine a young person that tries to deviate from the beaten path, some scientist that gets attacked in the same way. How would they be able to establish a career? I mean, they have no way of fighting the fight. And
right.
I'm
And
sure there
then
are lots of, and in fact, I heard from a lot of young postdoc students that had very similar experiences.
mm. So, the anti-tail. What is the going theory now about
Yes.
how what could cause
So
it? Yeah.
yeah. So what we proposed in the first paper was that the anti-tail is made of large chunks of perhaps ice, that so that these large chunks are not being, they have a small cross-sectional area per unit mass because they're big, and so they don't get much of a pushback from the solar wind or the solar radiation, and they don't turn around. And so that's why you get such a jet in the direction of the sun. If you imagine a technological origin for this anti-tail, you might say, well, the solar wind, especially flares and all the coronal mass ejections, they could cause damage to electronic devices passing close to the sun. So one way to protect them is to basically deflect the solar wind with a jet of particles. Okay, and
Mm.
so that could be a way of defending your electronics or whatever technologies one is using from any damage created by the outflow from the star that you're passing next to. So that could be another possibility. I also did some calculations about if it was made of dust particles, how big they should be, and they should be bigger than 10 microns. And Once you make them much bigger than 10 microns, if you make them a millimeter in size, you start getting into a regime where there is too much mass coming out of the object that you can't accommodate. The mass loss rate is so big that the object would disappear with the necessary mass loss rate given the size of the anti-tail. So yeah, it could be either particles in the 10 micron, 10 to 100 micron range, like very large dust particles, or it could be a beam of particles that is artificially created.
How massive is this thing compared to other comets?
It's roughly a kilometer in radius, so it's pretty big compared to Oumuamua, that was at least 10 times smaller in radius. And then it was another factor of 10 smaller in width, because it had a very extreme shape. Borisov, the second interstellar object, was a few times smaller. So it's a pretty big thing. It's the biggest interstellar object that we have seen, and that raises the question of why do we see such a big thing, or maybe we are mistaken and the object is actually smaller. I actually was on a paper this week, just a few days ago, that tried to estimate the size and the mass of the object based on the measured non-gravitational acceleration that it has and the mass loss rate. So when an object loses mass, you get the rocket effect if the mass is flowing in a preferred direction, just like a rocket. And so, from the amount of mass being lost that we can measure based on the plume of gas and dust around it, we can estimate how much momentum is given to the nucleus, because we can also calculate the speed by which this mass is lost for a natural process, sublimation process. And so from that, if we detect the acceleration of the object, we can tell how massive it is, because if it's very massive, it will not be accelerating much as a result of this calculated force. If it's low mass, it will be accelerated a lot. And so we calculated the mass and the size of the object just based on the rocket effect. There are some uncertainties in this estimate, but it gives, at least the size of a radius of 400 meters or so, and perhaps more than a kilometer, comparable to the estimate from the brightness profile from the Hubble Space Telescope.
So you also mentioned this other object, which I hadn't heard about, Comet 2026 MAPS.
Right.
Might have some relationship to this object. Can you talk about the possible connection, Avi, between this MAPS object and the 3i Atlas?
Yeah, it's not likely to be connected because, the only reason to think about it is because it was only discovered in January. And you might ask, why was it discovered only in January? It's actually a sun grazing comet. It's a comet that comes extremely close to the sun, within a few times the radius of the sun. That's amazing. And then the question is, within a week from now, it should become very bright because it should get ablated. But that's one way of figuring out the nature of comets. If they are grazing the sun, it's like putting someone whose nature is unclear under interrogation. You increase the pressure on the subject that you're studying, and in this case it's the sunlight basically evaporating any solid material, including if it was made of even metal, it would have melted when it comes so close to the sun, because the temperature there is thousands of degrees and at the surface. And so we would see what this object is, how quickly it breaks up. But the fact that this object was only discovered in January raised the question of whether it's related to 3i. Maybe it's a fragment that was peeled off 3i Atlas, but unfortunately, it has nothing to do with it, because the inclination is very different. Also, the estimated size of this particular comet, the sun grazing comet, is comparable to that of the nucleus of 3i Atlas. So we would have seen it long ago as part of 3i Atlas, and also, the trajectory is very different. So the orbital planes of the two objects are different by 30 degrees. That's the difference in
Do you
inclination.
expect in the future with Rubin and other instruments we'll see, binary comets, interstellar binary comets like that?
Definitely. Well, it depends if they exist, but we should see dozens of new interstellar objects. And by the way, my recommendation is that whoever is going on dates, don't marry the first person that you meet on a date, because you just don't have a good enough sample to decide how exceptional that person is, right? And so the lesson in the context of interstellar objects is we had only 3 discovered by telescopes. But now the Rubin Observatory will increase the sample to perhaps several dozens over the next decade. And that will allow us to figure out how unusual is, for example, Oumuamua or 3i Atlas. Do they really belong to populations of a lot of other objects similar to them? So just to give an example, the most detailed paper that analyzed the Hubble Space Telescope data concluded that we missed a lot of 3i Atlas-like objects because of the large abundance that they concluded. In order for us to detect it, there should be a lot of those, and we missed many of them because they are much brighter than Oumuamua was. And so we should have seen them, and we didn't. So maybe the Rubin Observatory will find many more. And then also Oumuamua, we should have seen 100,000 of those small ones for every big one. So where are these? And I'm really curious to know if there are populations of objects that contain many of them that look just like Oumuamua or like 3i Atlas. and we just don't know because the sample is not big enough. And if we don't find them, that would make both of these objects quite anomalous. If we never see an object like Oumuamua or 3 Atlas, we would start asking, why were we lucky to see them in the first place?
Yeah, and it's not every day we get dating advice from two astrophysicists. I tell young ladies when I counsel them, when I giving advice to some woman who asked me for how do you meet how can I meet the perfect man, and I say it's impossible. My wife got the last one. Okay, Avi.
No,
Now,
no, wait. I have another dating advice, which I think is quite important. And that is when you go on a date, aim high, don't aim low. There are
mm,
many more, mediocre dating partners than exceptional ones. And you need
yes,
to aim. It's very easy to find a mediocre dating partner. Okay. Now, how is that related? Well, most of the astronomy community is invested in searching for microbes. In the astrobiology community, that was the first priority of the decadal survey. To work on the Habitable World Observatory. All of that is in seeking evidence for microbes. And, I am saying let's search for something more intelligent than we are, not aim low and look for the most common thing. Now, you might say it's easier to find the most common thing. Well, it's much more abundant, that's for sure, but it's not necessarily easier because, if we happen to have a technological gadget flying through the inner solar system, the evidence might be easy to
mm.
identify. So it's all a question of how easy it is to detect oxygen, methane, other gases that are indicative of life on exoplanets, and make sure that these gases are not made by geological processes, compared to detecting or taking a high resolution image of an interstellar object that will demonstrate buttons on the surface and that is not a rock for sure.
Well, yeah, I want to turn to things that could or could not be rocks. Here we have an image of some debris, but perhaps something more mysterious. So on screen now, if you're watching on the YouTube channel or on Spotify. By the way, we are going to get questions from the audience in a little bit coming up soon. Uh, but there's a strange looking object. It sort of looks like a truncated cone. And it's an image from the
Yes,
mast camera aboard NASA's Curiosity rover that's actually almost 4 years old, 3.5 years old now.
right.
So it's taken in 2022. So they found this mysterious object. It looks like a cylinder or fragment of a cylinder. What is, as a scientist, what was your first reaction to seeing it? Technology, alien
I
technology? It's
couldn't
definitely.
believe
It
it.
seems. Yeah, it's hard to resist the call that it could be technology, but it could be natural. So what do you make of it?
No, I
We'll
think
zoom in
it's
on it.
definitely I think it's definitely technological, because if you look at it, it's very distinct relative to the background regolith or rocks near it. It's about 20 centimeters in length, and it's buried partly within the regolith, so it's not like it's sitting on top of it. And the question is whether it came off Curiosity, the rover, or something else that flew above this region. And the point is, it was not noticed by NASA. It was noticed by some amateur. And then when you go back to the data set collected by the cameras on board the Curiosity, you find the views of it from different angles. So it's suddenly out there. And my point is, this right now, Curiosity is about 8 kilometers away from this object. I think we should go back. I mean, at the highest speed of Curiosity, it would take 2 days to return to that location. But of course, there is topography to cope with, so maybe it will take, I don't know, 2 weeks. I think it's worth going back and checking what this object is, because
Mm.
if it's not human made, it's very curious. And after all, this rover is called Curiosity, and I think it's ironic that the operators of the rover are not as curious as they're supposed to be. And NASA didn't make any statement about this. They basically are completely silent, which is really strange. I mean, what's the goal of doing science if not attending to anomalies, to things that are really strange looking, and we should figure them out. I mean, I don't know how much, how many exciting tasks they have for Curiosity to accomplish in the coming weeks. But compared to this one, I would put this one as the highest priority. When I pointed this out based on the discovery by other people, by the amateur, um, uh, it became viral within the public. I mean, and a lot of people agree that this should be looked into.
Oh, definitely is a fascinating object, and yeah, you have to look at their prioritization. What else is good use for this for the rover, which has the capability to go view it. But for me, it brought up an interesting kind of paradigm that I've been thinking about for a long time, which is that it's almost certain there's life on Mars. It's just the question of whether or not it's from Earth, right? Because I have here this meteorite I keep promising I'm going to give to you when we meet again, but this is from the moon. You won't get this at my website, briankeating.com /YT, but you will potentially get one of these. You'll definitely get one of these metal iron meteorites if you have a .edu email address, briankeating.com /edu, and you live in the US. But others I do give out on occasion. But this is from the moon. I do have a piece of the of Mars, which is similar to the one I gave to Joe Rogan. As I joke, he hasn't sent me a thank you note for it, but it might have been smoked. I can't. He might have ground it up and done. Anyway, but this object came from the moon, but I have Martian meteorites as well. Not collected by rovers, collected, delivered by gravity, and that's because the Earth and Mars exchange material at the rate of many, many
Oh yeah.
tons per year. So there's likely a time in the Earth's history where the Earth was wet and moist and full of life, and Mars was wet at least and could have and warm and enough to support life. So the fact that we don't observe Martian life now, can we use that to set a prior on the fecundity and the fertility of rocky planets, or is it
No.
really kind of too difficult to employ a Bayesian framework in that way?
Based on what we see on the surface of Mars, there is no doubt that there were lakes, rivers, oceans of liquid water, just like on Earth on early Mars. And in fact, Mars cooled before the Earth because it's a smaller body. The cooling is proportional to the surface area. The amount of heat that is stored in a planet scales as the volume. And a smaller body has a larger area per unit volume of the object. So that means that it cooled earlier. And if it was as fertile as the Earth, it might have developed life before Earth. And the two planets exchange rocks. We know that for sure during that early time because they were bombarded by asteroids. And it's possible that life started on Mars, delivered to Earth. That's more likely than the other way around, I would say.
Mm.
And in which case, we are all Martians. And when we think about going back to Mars, it's like going back to our childhood home, in a way. It became a desert about 2.5 billion years ago when it lost its atmosphere.
Mhm.
So that's a separate matter because, I mean, it's a smaller object and the magnetic fields were not strong enough and it lost its atmosphere, became a desert. But the possibility that there was life on it is very high. And in fact, it may have been delivered to Earth. It might have been the same form of life. There is a whole debate about the results from the Viking spacecraft that visited Mars, collected some material. For example, I was just corresponding this morning with Stephen Benner argues that the Viking results indicate that there is life actually in the soil, and we just didn't do the right experiments, the right interpretation of the Viking experiment. And in principle, if you drop a drop of water, let's say on the Martian soil, it would be very interesting to examine the gases that come out. Unfortunately, NASA never followed on Viking. They became very risk averse. They didn't want to get into controversies. They sent rovers, but didn't do the elementary experiments that would indicate if there is life in the soil that could be revived. And in principle, it could be there. And the whole story of transfer of life, panspermia. This week there was a new paper that was published saying that there was an experimental team that took some extremophiles, some microorganisms, and put them under very extreme pressure, up to about of order 2 gigapascals, about
Mm.
10,000 times the atmospheric pressure on Earth, and they realize that they can survive. So that means that during a meteor, an asteroid impact on the surface of a planet, where you get a very high pressure blast wave that basically chips off some surface rocks, microbes could survive. And then there is one rock that was brought to that landed on Earth and was analyzed about 46 years ago, and was found not to be heated. It was never heated above 40 degrees Celsius. Any microbes, any tiny astronauts in the core of this rock would have survived, because it was never heated when it was chipped off the surface of Mars all the way until it landed on the surface of Earth, never heated more than 40 degrees Celsius. And so definitely the transfer of life is possible between Mars and Earth, and also in other planetary systems that are densely packed, like TRAPPIST-1. It has 7 planets that are close to each other. We don't know if there is life there, but if there was on one of them, it could have been that planet could have infected or spread life to others. All of these are natural processes, by the way, the panspermia, but there is also a possibility of directed panspermia, where intentionally, deliberately, there is an interstellar gardener that decides to spread the life throughout the Milky Way galaxy, and that could be far more effective. In the context of rocks, we think about just like the dandelion seeds are being spread by the wind, and they sometimes land on fertile ground, and then they produce more dandelion seeds. But in the case of a deliberate process, you can spread life far more effectively. We can do that, by the way, if we were to plant microbes in the belly of 3A Atlas. We could have intercepted 3A Atlas and dropped some microbes in it, so that when it comes close to another star, they might spread and perhaps land on another planet
Mm.
far away.
So speaking of Mars and the Martian, this week the movie Project Hail Mary came out, and it is a delightful story. I've not watched it yet, but it's from the author Andy Weir of the book The Martian. He's
Yes.
actually like Mark Zuckerberg. He went to UCSD, but he didn't graduate. So it's kind of our
Well,
eternal shame.
maybe it's a good thing, because otherwise we won't hear about him if he were an academic. But I'm planning to see tomorrow. Yeah,
Yeah.
I
So
mean,
let's talk.
you never know. Life things that you regard as unfortunate events during your life may be actually a blessing, because they
That's
direct
right.
you, yeah, in an original path. Yeah.
So, moving on from The Martian as a blockbuster movie to I'm just showing in the background a video interview I did with Andy Weir a couple of years ago when the book first came out. What about the scenario? I mean, it's not a spoiler to say, it's about aliens and the possibility of alien microbial life that attacks the sun. What do you make of this scenario that he's outlined?
Well, there could be an impact. I mean, just like the pandemic that we went through, you can imagine alien microbes approaching Earth. That could be a real serious issue, and that's why I would never shake the hand of an alien. If we have a visit and they happen to land in my backyard, I would never shake their hand. I don't, I'm worried that they might bring disease. It's just like the visit of South America by Europeans, and the biggest weapon that was used was the disease, the spreading of the disease, which was pretty bad. So I would be quite worried about that. There is also the possibility of mirror life, which is quite harmful to our bodies. That if you have all of life on Earth has a particular helicity. The molecules are oriented in a particular way, and you could have an identical chemistry if you had the reverse orientation of those molecules, an opposite helicity. And so if there is a visit by life with the opposite chirality, I should say, then it could be quite dangerous to us, because our body would not detect viruses or microbes that are of the opposite chirality. So
Right.
we should be careful. So definitely there could be a risk to life on Earth from visitors. uh, I'm not sure about the sun, because the sun will simply burn up any life form. So I don't know about the storyline there, but
Right.
I would be less worried about the sun.
Yeah, exactly. So, moving back to terrestrial, news, you published something I thought was quite clever about the State of the Union, but you instead of State of the Union, you changed it to State of the Universe. What is the state of the universe right now?
So first, I should say that in all the textbooks about the universe, cosmology, and some of which I wrote, um, we think about the universe as a cold and lonely place made of matter and radiation, and we describe the dynamics of matter and radiation using the equations, Albert Einstein's equations, and hydrodynamics and so forth. And uh, this perspective that we have about the universe would change dramatically if we realize that there are intelligent beings out there, because then we will have an emotional connection to the universe. If they visit our backyard, we might want to visit their backyard. It will make the entire description of the universe quite different, because intelligence allows for I mean, we often talk about free will. It allows for new realities in the future that do not resemble in any calculable way the past. The whole point about intelligence is that it involves such a complex set of considerations that you can't just plug the initial conditions and end up with knowing the final what will happen. And that's why we have this idea of free will, where we are responsible for what will happen in the future. It's not like you can attribute everything to the initial conditions, put it into a computer, and figure out the final outcome. So if we find intelligence out there, the perception of the universe would look different. In principle, all the siblings in our family of intelligent civilizations can unite and decide for a brave new world where we would do something, some cosmic engineering. I corresponded about that about a decade and a half ago with Freeman Dyson about cosmic engineering. What can we contemplate doing in collaboration with other civilizations? For example, coming together so that we don't get separated from each other by the cosmic expansion, things like that. But the state of the universe, without knowing about the intelligent beings, is pretty much depressing, I would say, because we see the universe at large expanding, and not only that, but accelerating its expansion. So once the universe gets older by a factor of 10, according to the standard cosmological model, uh, uh, all the galaxies that we see, all the sources of light beyond our own galaxy will move away from us faster than light. And that means that we won't know what the whereabouts of anything except for our own galaxies. Our galaxy will be surrounded by vacuum, and there will be darkness outside, except for the stars that get ejected from the hypervelocity stars getting ejected from the Milky Way. They will be the only tracers of what happens outside the galaxy. And other than that, we'll have our own galaxy. And it's pretty depressing if you think about it, unless there would be some, Deus ex machina, some unexpected behavior of the constituents of the universe. So right now, the most popular idea is that we have a cosmological constant. If it's indeed constant, the acceleration will continue forever. And by the way, the most common stars are dwarf stars, about a tenth of the mass of the sun, and they could outlive the sun by a factor of 1,000. They can live up to of order 10 trillion years, and the sun will die within 7.6 billion years. And you may ask yourself, how come we exist near a star like the sun when the most common stars are smaller and they live longer? Why? I mean, the most likely situation is for us to exist next to a dwarf star in the future. There is much more time in the future. There are many more stars like dwarf stars. How come we exist near the sun today? And one possible answer is because dwarf stars are faint, and so the habitable zone, the region where life can exist around them, is closer in. And if you put a planet there, and in fact we know of a planet near the nearest star, Proxima Centauri, has a rocky planet in the habitable zone, but it's 20 times closer than the Earth-Sun separation. And that location, the planet is vulnerable to eruptions from the star, to flares, to the stellar wind. And it's possible that the atmosphere of rocky planets in the habitable zone around dwarf stars, uh, the atmosphere gets ripped apart, it gets stripped, and so life cannot exist, because the situation will be similar to Mars that we talked about before. If a planet loses the atmosphere, there could be no liquid water on the surface and becomes a desert. So it's possible that all the habitable planets around dwarf stars are basically like Mars. They lost their atmosphere, and therefore they have no liquid water on the surface, no life on them. And that's why we find ourselves next to a star that is not typical, like the sun, where we can be far enough from the star to maintain the atmosphere of the Earth. The Earth is a big enough planet to keep its atmosphere. So, it's a very interesting question. There would still be nuclear furnaces, stars in existence up to 10 trillion years from now. Even when the universe gets dark and lonely, we could still live there. Our descendants would still be around near those campfires, these dwarf stars. But we might do some cosmic engineering, to make
Mm.
our life better, and not just rely on those nuclear furnaces, that nature gave us. Right now, we rely on the sun, but in the future, we might build a space platform that has its own nuclear reactor. It doesn't rely on, fusion in the sun, and because the sun will eventually die, and everything dies in the universe. It's
Mm.
really. I once went to an optometrist office, and the receptionist was complaining that things change too fast with the computer system, and I said everything will change. The sun will die one day, and she said, "Really? Are you sure about that?" And I said, "Of course I'm sure, because how do you know that we will die, that you and I will die? It's because you go to a graveyard and you see, that people, whatever remains from people that existed before us, they died, and the graveyard of the Milky Way galaxy is full of corpses of sun-like stars that died by now. These are called white dwarfs. You can see them. There are billions of white dwarfs that represent stars like the sun that died by now. So we know that the sun will die." And she said, "Oh, that's too bad. It's against my religion." And I
Mm.
said, "Sorry to be the bearer of bad news, but we know it for sure." And so, everything good lasts for a while, but then goes away. And we should make plans. If we want our civilization to be remembered in the history books of the Milky Way galaxy, we want to leave the Earth, and not by going to Mars. That vision that Elon Musk had, I don't think that's the right approach, because it's a rock that is less hospitable for life. It doesn't have an atmosphere, it's a desert bombarded by cosmic rays. Why would we go to a worse place from a place like Earth? The,
Right.
the, the best way for us to leave Earth would be to produce something like Noah's Ark. I call it Noah's spaceship, where we build a platform the size of a city that can accommodate humans, produces artificial gravity. And if we can do that, maybe another civilization did that, and if we find those spacecraft, it will inspire us to do it.
Well, you speculate in one of your articles on Medium that an AI system might detect alien signatures and that maybe alien intelligence itself could be artificial. So, if we find something, how do we tell the difference between a biological artifact or from a biologically active civilization or an autonomous AI probe? How could we distinguish that? Could Galileo probe project distinguish it?
Oh yeah, that's an excellent question. So it really depends on how long the journey was as to whether we will encounter biological or technological objects. I mean, I think most likely it will be artificial intelligence that is guiding whatever gadget comes close, because the benefit of that is that it doesn't get bored. The AI system can stay around. You can make it sufficiently um, robust so that uh, it doesn't need to get any guidance from the senders, because the time it takes a signal to cross the gap between the sender and the craft is so low, is so large. And we are used to helicopter parenting our rovers on Mars from the Jet Propulsion Lab in Pasadena. But when you engage in interstellar travel, you don't have that luxury. And sort of like sending your kids out of home, you don't expect them to report back on every step. Perhaps they will send a message once in a while. But uh, that you need to have any such interstellar traveler needs to have its own brain to decide what to do under unexpected circumstances, and I expect that to be artificial intelligence. I mean, we have exponential advances in our AI systems, and just think what they may include within a century from now. So far, we haven't launched to space an AI guided rover or spacecraft, but I think that's the future. Um, and on the other hand, we might decide that to use AI assisted medicine to augment the human body such that it could survive very long journeys, like millions or billions of years. And that could also be something that we encounter, some mixture of
It,
a
it
technological and biological organ.
It also occurs to me, feeding off of your previous comment about chirality and opposite handedness and so forth. But it might be that an AI wouldn't care about humans at all, and it might just care about our AIs, which will outnumber humans. By the same ratio as microbes outnumber humans pretty soon. I mean, we're talking less than 10
Right.
years. Uh,
Yeah.
so and if they did that, wouldn't it be much more efficient for an AI to talk to another AI? I mean, a computer could talk to another computer. I mean, we gave it these concepts and for loops and all sorts of structures and now we have AI models, LLMs, neural networks. But they might have a much easier way of communicating that's at a meta level that we can't understand. It's like
Yeah. I
our
mean,
our dogs communicate in ways that we can't understand, right?
but there are two requirements for that. One is the architecture of the two devices that are communicating need to be to be matched. They need to sort of connect in the way that they think. And the second is, of course, they need to have sensors that allow them to detect whatever the other entity is transmitting. As of now, the AI systems we use only has access to the internet, doesn't have sensors that communicate with another AI system the way the human brain does. I mean, we have ears, we have a mouth that we can speak, and so. But in the future, maybe with robots, that will be possible. A robot connected to an AI agent could potentially serve as the analog of biological systems. And with respect to artificial intelligence, we should think about it as alien intelligence. I mean, we often, people discuss aligning AI systems to our guiding principles, but to me, it sounds like trying to put lipstick on a pig, in the sense that we're trying to make it resemble us, but it's really a very different entity. Because it's made of silicon chips and not flesh and blood. And if you ask me what's the biggest danger in the future, I'm not so worried about job losses and things like that. I think the biggest risk from AI is that it will sabotage the human mind, in the sense that it will make humans dumber. And I already see signs for that in students and postdocs that I interact with, those that are addicted to AI agents. uh, they are losing their edge. They are not as bright as I remember students and postdocs being a decade ago, that didn't
Yeah.
have these tools. It's sort of like you have the ability to use public transportation and you're not using your muscles to walk anymore.
Or you're
So
using. I mean, how often do you not use GPS in your car? Or how many phone numbers do you have memorized right now?
yeah, right. Now, in the context of doing science, there is now a new AI agent that can write papers for you. You just have to guide it, and it will do all the work for you. And I know of a number of people who are using AI quite routinely, and they say that it's doing better, much better than their students or postdocs.
Yeah.
And in fact, one of them said that it's performing better. It's performing 90% of the tasks that this distinguished researcher performed throughout his career. And so that is a remarkable milestone. I think in recent weeks, AI systems are really making a difference. And I can tell you that a few weeks ago, this meteor that I mentioned that we discovered with my postdoc, it took us 10 minutes to do the analysis, asking an AI agent to help us. Whereas when I asked an undergraduate student 6 years ago to do the same, it took a week. And
Hmm.
so it's definitely an amazing tool now in making science progress faster. But we have to be careful. For example, you can't test students in the class. The question is, what is the purpose of education? Okay, so education will not be about the transfer of information anymore, because you can get the information from AI. It will be more about teaching students how to think. And if you want to test them, you have to put them in a Faraday cage, because you don't want them to use AI or any other electronics to figure out the answers. And you have to
Unless
do it in
we use
person.
AI to see if they're using AI, and it becomes
Yeah, and the question,
counterintelligence.
I'm quite
Need
confident that
Mossad agents in every classroom.
I'm quite confident that a substantial fraction of papers being written right now, maybe even more than 10%, are being written by AI, and some of them are faking either the results or the calculations. And I'm not sure that the editors of journals are able to catch those.
Yeah,
And I had the experience of seeing a paper written by some postdoc in Europe, and I thought, who is this postdoc? How come he knows so much about asteroids? And then I looked at the other papers of this postdoc on the archive, the astrophysics preprint server, and I saw that he wrote a paper about the early universe, what happened around the Big Bang, inflation. He wrote about a large range of topics, and I thought to myself, how come he's so broad? He's just a postdoc. And then I realized that none of these papers were submitted for publication. These are all papers written by AI, presumably to beef up his curriculum vitae, his CV. And we have to be really careful about assessing the statements being made in scientific papers. I think AI poses a huge risk to science in terms of misinformation. And I experienced that personally when about 4 or 6 months ago, there was a website that imitated my voice and my image, and it was AI generated. And some people created a YouTube channel that provides misinformation and of content that I do not approve of. And then I let it go because I wasn't sure how dangerous that is. This website got 1 million views within a week, and they made money out of it, out of my name, basically.
no.
And I continued to let it go because I was busy with science, until an old lady, 82 years old, who came to my office and said, my name is Abby Rockefeller. I'm the daughter of David Rockefeller. And I wanted to tell you that there was a video with you in it that was very attractive. I really believed it. And I shared it with my friends until one of them told me that it was completely fake. And so
Yeah,
I was very frustrated, she said. And as a result of that, I decided to establish my own YouTube channel so
yeah.
that once I get 100,000 subscribers, I established it about 2 months ago, and I have already close to 30,000. So once I get to 100,000, then I can basically ask the authorities at YouTube to remove all the fake channels. But the bigger problem is that the public gets fooled
Yeah.
and misinformation prevails. And how can you judge if something is real or not these days? That's the big question. And I'm actually doing right now, today, just an hour ago, we asked volunteers to fill up a survey regarding fake versus true images and content, because I think that is a very serious problem for the future of science.
So we'll put the link to your YouTube channel in the show notes down below for the podcast and whatnot. But so the final question I want to ask, involves AI as well. And if you know, it occurs to me, you've spoken a lot about biosignatures and maybe a little bit about skepticism of it. We've talked obviously a lot about technosignatures involving possibilities of these interstellar objects being extraterrestrial technology. But it seems to me that if we move to extraterrestrial artificial intelligence and transitions from biological to digital, then we might need to look and study at different kind of modalities. Perhaps what would an AI technosignature or what would an AI signature be? Would it be waste heat? Would it be some sort of computational louder limit, kind of
Yes.
violation, or what would it be looking? What should SETI be looking for? If you could, talk sense into some of your
Yeah.
SETI detractors.
Yeah, that's an excellent question, because SETI was founded 65 years ago by Frank Drake.
Yeah.
searching for radio signals. And frankly, radio communication at the time was quite important on Earth for us, but it was, by now it's regarded as an old technology that we don't use as much for communication. And in fact, future communication will probably be using lasers in the optical and so forth. We have optical fibers already on Earth. The question is how the advance of technology changes the means of communication of extraterrestrials. And when you look for leakage of signals, what should you look for? And uh, there could be other technological signatures that have nothing to do with communication. For example, if a civilization resides on a planet like Earth and wants to bring cargoes to a planet like Mars, but they want to do it with light sails, meaning giant membranes that are being pushed by radiation. It turns out that if you want large cargoes that are many tons, you want to use radio waves for that. Okay, and uh, then how would we detect that? Because the beam that is pushing the light sail may have some leakage around the light sail. But how would you know that it's related to a light sail? Because you would see that the two planets in conjunction, they would appear along your line of sight when you detect the signal, because that's the direction that the light sail is heading towards, from one planet to the other. And it could be at different wavelengths, but it would be very different from a communication signal, because you would get a burst of radiation this way. And I actually was involved in a paper with James Gwilichon back in 2015 that we wrote about this. But then later I was wondering, together with my former postdoc, Manasvi Lingam, whether some of the fast radio bursts would be related to that. Turns out that if you want to bring a spaceship close to the speed of light, you need to use roughly the amount of power that is impinging on the surface of the Earth from the sun, and shine it on a light sail that carries a giant spacecraft. And then this beam of light, when it crosses our line of sight, would appear as a fast radio burst. So, that there is a question of whether all fast radio bursts are related to magnetars, neutron stars, or something else.
Right.
Um, and then you could look also for artificial lights on the night side of a planet. There is a company now that wants to illuminate the night side of Earth by putting mirrors in space. That is
The
a big
Russians
risk.
tried that 50 years ago. The Russians tried that to get more work efficiency out. I think they also had like a 10-day work week, or maybe that was the Chinese. But
Yeah.
yeah, they
So
tried
now
to.
there is a company that wants to do that with 50,000 mirrors. That will be a big risk to astronomy, because they will blind the observatories if they happen to shine on those. But the point is that if you imagine a very ambitious technological civilization that illuminates the night side of a planet, you can easily tell that as the planet moves around the star, because you will not just get reflected light from the day side, you might get some light from the night side of the planet. That's something that was never sought, never searched for. You
Hmm.
can look for industrial pollution in the atmospheres of planets, not just for oxygen or methane, the way that the astrobiologists are thinking about. Just look for molecules produced by industrial origin. And we should look for packages in our mailbox, objects that arrived into the inner solar system. These are all methods that were not employed by the SETI community in the past. I have no issue with the fact that they focus on what they want to do, but I have an issue with the fact that they ban discussions on some of these methods in their conferences. For example, they will not discuss any unidentified anomalous objects in the conferences. If the US Congress, if the US government talks about it now, I think it should become a subject of discussion within the astronomy community, within the mainstream of SETI, and within the mainstream of astronomy. There is no reason for us to ignore a subject that serious people are discussing, former presidents, current president, Congress, Pentagon, intelligence agencies. When there are things that are not understood by serious people, scientists could come to the rescue and figure things out.
Yeah.
And that's what makes life fun, making it a learning experience. I often said, and I said that I gave a physics colloquium and a public lecture just 2 days ago at Notre Dame University. And the opening sentence of my talks was the foundation of science is the humility to learn. It's not the arrogance of expertise. And what you find in academia very often is the arrogance of expertise, as if we should know in advance the answer and we should brag and show off that we are experts on something. But the point is, nobody is an expert. We should have the humility to acknowledge that nature could be more imaginative than we are. And we have an opportunity to learn if we only open our minds, if we don't insist that everything in the sky is rocks, but we say we launch space probes, we launch space technological objects to space. Therefore, someone else might have done that. We may not be at the top of the food chain. We should be open-minded to that possibility and increase our learning data set, the training data set to include technological objects. And only then we would know if they exist or not. But if we insist in advance on knowing the answer, we will maintain our ignorance forever.
So, the final question for you before I let you go is, kind of reflecting on your career and how many wonderful conversations we've had over the past, 4, 5, 6 years now. And I've known you and looked up to you for a long time before that. You spent your whole career looking at theories, creating new theories, teaching people, writing books, writing textbooks, building instruments, leading groups, and making the case, that it at least should occupy a big sliver of our intellectual capital and our financial capital. And now the government is registering domain names, and we see objects are arriving faster than we can catalog them. The Rubin Observatory released tens of thousands, hundreds of thousands of interesting objects in the time domain. And AI, as we said just now, is about to change what even detection could possibly mean. It seems to me like all these threads, which were so disparate for so long, they're finally converging into a tapestry. And I'm wondering, are we the last generation that's going to wonder if we're alone? And if so, are we ready for the answer that we might get?
It's quite possible that the best is yet to come and it will come soon. And that would make my life worth living, if it happens. I certainly wish it on all of us to realize, if we have neighbors, to know that. And if we don't find it, at least I made my contribution to allowing future generations to make that discovery. The biggest thrill I have is when parents come to me and say, my kid watched you on television, now they want to become a scientist. And the reason I'm thrilled about it is that here is a chance for someone without a prejudice, without being obsessed with their ego, making a discovery of an important truth that my generation of scientists didn't discover. And so I'm always an optimist, because sometimes life is a self-fulfilling prophecy. If you allow yourself to imagine a partner better than you are, then you might find that partner. If you say, where is everybody? I don't see anyone around me. And frankly, I'm quite exceptional. And therefore, I shouldn't hope for anything better because I'm at the top of the food chain, which is a narrative that many people in academia and elsewhere are using. And you say that it's an extraordinary claim to imagine something better than you are. Then, of course, it's a circular argument. You may be left on your own forever because you will never search for that evidence. And I can only imagine being an alien and looking down at Earth and seeing what people are obsessed with. All these fights and conflicts that make very little sense in the cosmic scheme of things. We put most of our money, most of our resources on fighting each other, impressing each other on this tiny rock that we were born on, whereas most of the real estate is way out there. And most of the interesting stuff is way out there. We're not looking out there. We are playing in our sandbox and impressing each other. And that's ridiculous. That's pretty much ridiculous. So that's why, I was asked actually by Natasha Zuves, the reporter from, she interviewed me for 90 minutes from News Nation. And she said, aren't you afraid that if we encounter extraterrestrials, they will be hostile? You might die during the encounter. And because she's fearful of that encounter. And I said, well, I'm happy to encounter them, even if my life will get shortened, because it will be a thrilling experience. And I prefer to have a thrilling life, short life, than a long life that is completely dull, just watching News Nation report about all the nonsense that is going on around the world right now. What's the point of living a long life that is quite dull?
That's right. Yeah, the lifespan, should be matched by the curiosity span. And Avi, you're one of the most curious and imaginative, creative, and really just all around fun. People don't realize that Avi is out there having fun while you're criticizing him, while you're trying to take him down, while you're making videos. Avi's just having too much fun, and you can't win. You can't beat someone who's just having fun because you're not out there to win Nobel prizes and to get sell billions of dollars of books. And we'll talk about your media in the future. I think you've got a lot of interesting
By
stuff.
the way, just an hour ago, I had an interview with a German reporter, and he said, "Does it bother you that there is so much anti-Semitism in the U.S. and people attack you? And sometimes, some of the YouTube videos, especially
Yeah.
by a guy who calls himself a professor and was never in an academic position, so he's lying about himself. But then he also uses some anti-Semitic narratives. Doesn't it bother you?" And I said, no, I prefer not to mud wrestle because that gets everyone dirty. I just ignore those people. And I pretty much hope that they have a therapist that will solve their psychological problems. I'm not here to solve their problems. I'm here to seek, one reason I'm seeking higher intelligence in space is because I don't often find it here on Earth.
Well, Avi, this has been great. We'll catch up again soon. Thank you very much for another fascinating set of anomalously entertaining ideas, and we'll get to more as the year goes on. Thank you, Avi. I'm going to stick around, just talk to a few people on the podcast, but yeah, you're free to go. Shabbat shalom to you, and I hope to be in touch soon.
Thank you so much.
Bye, Avi. So that was a lot of fun. I just wanted to point out we're continuing to grow the podcast and grow the YouTube channel. It just keeps expanding like the universe or my waistline. I can't tell which is going faster, but it's really a stunning series of interviews that are coming up. I just did one with Vivian Ming, who's one of the foremost experts, neuroscientists, was here at UC San Diego, but she has gone on to do great work in terms of making both yourselves and your children, especially, into robot proofing them to make them immune to hopefully some of the threats to their careers and to our sanity and to our own well-being that AI presents. And she's a big proponent of AI, and she's worked with Google and the CIA and Facebook and all the top organizations. That'll come out in a couple weeks. But on Tuesday, I have an interview with Michael Wong, who's a co-author of a book called Time's Second Arrow, where he and his co-author are both geoscientists at the Carnegie Institution, that they claim they've discovered that the second law of thermodynamics is sort of wanting, and in fact that there must be a new law of thermodynamics. So we talked about that, but where that gets interesting is that we dovetail that in with the different arrows of time that we know to exist, including biological time arrows, and we actually got into a very interesting discussion on planetary habitability and alien life support. And so that is not to be missed. It's really a unique conversation with a very broadly, kind of widely and broadly discursive mind, and provocative too. To conjecture that you have discovered a new law of physics is quite astounding. So you'll be the judge. I push back with my requisite love and respect, but I think it's worth really digging into. And so that'll be out early next week. And then after that, interviews with Matt Kaplan of The Economist magazine about his new book, I Told You So, which is about scientists that were doubted and even perhaps driven mad and to the brink of, in some cases, suicide due to their ideas, which were later proven to be correct, but not taken to heart in their own lifetime. So it's quite fascinating to witness what does that have to say about science and adoption within the public sphere right now. I think it's a very timely book. And then lastly, in the next 4 weeks or so, we have a book by Rebecca Neuberger Goldstein. She wrote Plato at the Googleplex and other books as well. And her new book is about what it means to be a human being, so mattering. and meaning. And what's so surprising about that to me is it's a real physics book. She's known as a philosopher, but she actually studied physics at Princeton and took a class with John Archibald Wheeler, who talked a lot about a form of dark matter himself called black holes. In fact, he invented that term. And so she took classes with him, and he deeply influenced her. And so it turned from from a philosophy interview to a physics interview. So I hope that you guys will find that really fascinating and enjoyable too. I've got some really unique guests. I'm trying to not hit the podcast or kind of circuit. You could tell I haven't had on a lot of guests that I've had on many times in the past. I'm trying to get some new perspectives, new ideas. Everyone's talking about AI from kind of jobs and agentic and open claw and stuff like that. And I use that too. I'm using that on a daily basis for teaching, for research, and want to get into my upcoming paper, which was written by AI. I mean, I'm going to list AI as my co-author, and that's it's not related to my main research in the cosmic microwave background, but what it is related to is fundamental symmetry. So one paper I wrote with AI and one of my undergraduate students has to do with how do we know AGI is here. My claim is that it has to involve predicting some new law of physics, or at least, at the very least, being able to rederive laws of physics that we already know to be true. For example, general relativity. If ChatGPT existed in 1911, could it have predicted the effects of gravitation curve spacetime purely from the data that existed back then? In other words, could it exactly mimic what a natural intelligence, what Einstein did by coupling his computing device to his embodiment? His physical form was very important to him. He did have the famous elevator thought experiment, where if an elevator broke its cable, would an observer feel any gravitational force? And that led to the Einstein equivalence principle in 1907 to 1911, and then that became core part, and in fact, the biggest part of the general theory of relativity. So my conjecture is no, until an AI can reproduce what Einstein did based purely on 1911 and before physics. And the challenge is getting data sets that are uncontaminated training data sets. That are so hard to get training data that's pure and unadulterated by physics we've learned since then, because Einstein appears everywhere in movies and obviously all over the internet. And that's what training data sets are used to comprise training data sets. So I think it's a fascinating article. It turns out Demis Hassabis also conjectured a similar thing, 2024 Nobel laureate, for kind of knowing if superintelligence is here. And we started working on this back in 2023. So I did write a paper with AI and my undergraduate student, and I'm full disclosure, it's going to be in the paper. We'll see if it gets accepted, but to Avi's point, sometimes it's just important to submit certain things as long as they're high quality. The data integrity is there. It's mentioned that AI is a collaborator because it does allow you to scale out. Look, my graduate students are naturally intelligent. And so, whenever they collaborate on a paper, we list them as a co-author. So I don't see anything wrong with doing that as long as it's clearly listed. I do worry about the AI slop problem, so I'm going to be very judicious, only using AI for my non-CMB related projects. In other words, my own projects that I can have control over, so to speak. I am the PI of the Simons Observatory right now, but I don't want to use AI for issues investigating the cosmic microwave background, because I do feel like we want to keep that kind of detailed in the data analysis process and our methodology completely consonant with what's come before, because the stakes are so high for what we're doing with the CMB and the Simons Observatory to claim potentially that we see or don't see signatures of cosmic inflation when that data set comes out, hopefully in the next 2 years, maybe less. I want that to be completely done in accordance with best practices in the CMB field, which to date don't use AI for doing significant heavy lifting. I mean, it might do some literature search. I mean, there are LaTeX tools that work in that field. So my philosophy with AI is I'm using that for my own self-controlled, self-directed projects, maybe some more philosophical things like this AI Einstein test. And then for test of Lorentz invariance violation using an optical polarimeter that we built here in San Diego. And that will be hopefully to reveal the constraints, limits on cosmic birefringence and polarization rotation, and also on the variability of the speed of light as a function of polarization. So these are all things which I am not an expert in, in all the details of optical polarimetry, but AI can really come to the forefront there and help out in the process of methods and procedures, not in generating data. Of course, we'll generate our own data. That's the whole, fun of it. And so too with the Simons Observatory, taking, 2 years of data as of this next week, with the instrument, and getting to dig your hands into the data is what makes it fun to be a scientist. I don't want to have AI trusted with that or give that the fun, but there's things like literature searches and things that we might have missed, and actually AI has been helpful in terms of the business administration of the Simons Observatory. Like, are we getting having the best possible safety practices with visitors that come to visit the observatory, for example. I haven't, studied every single public observatory on Earth and how they get there. At the South Pole, you're not allowed to touch any and visit any of the observatory. So how do we do that consonant with best practices? And do things to encourage the participation of Chilean astronomers and Chilean public. They pay a lot of their taxes to support the observatory. I think that's a great use of AI. How can we best, kind of divide up, the amount of battery storage we have for electricity versus on-demand solar power? Can we use it as an uninterruptible power source? These are all great things that are not cosmological, but they are incredibly important to the functioning of an observatory. So we are using, kind of tools to help us in that realm, but we're segregating it, firewalling it off in many cases. And where we don't, we reserve the right to use it, but we're going to be very transparent about it. And I think that's the key. If our, collaborators, colleagues, and other experiments, if they can be use AI as a tool and reference it and cite it and prescribe what it can do and what it can't do, and also be completely open and transparent and accountable, which very few experiments have been, completely, outsourcing, open sourcing the data, but we have a mandate to do that with the Simons Observatory. So you'll be able to look at the data, even though it's a privately funded instrument for the most part. Most of the funding came from the privately funded Simons Foundation. You can see my interviews with Jim Simons, who passed away 2 years ago, almost exactly, and David Spergel is the current president. And that's a big mission, making the science open source and public and available. And it costs a lot of money and time to do that. It does, we're just going to leave you here's all our data on a disk somewhere. It costs a tremendous amount of time and effort, and it does, quite frankly, mean that we're not spending every single second on doing the cutting edge science that the observatory is meant to do, but we feel it's a trade that that we're willing to make it available to the public, because at all levels the public does pay our salary and allows us to do what we do. So thank you for the support. There's many, many cool things coming down the pipeline for me, for my group. Many, many cool, just unique interviews. Another one is with Ahmad Mostak, who's one of the co-founders, if not the founder of Stability AI, and he turns out to be a deeply closeted mathematician. I knew he had some math chops, but we talked about his book, The Last Economy, which is kind of a warning cri de coeur to get prepared for the coming AI tsunami, and that's more in the AI kind of warning. What's the value of human intellect when there's an infinite number of Nobel level intellects that come out? But I think can't wait to see what comes next. So stay tuned, and there'll be more interviews, and especially with him and his theories on physics as well. So you won't want to miss that interview. We did it in person last week. So stay tuned. Lots of things to come. Thanks for watching Into the Impossible. See you next time.